All remember an experiment of separating sand, salt and water we used to do at primary school. First we had to filter the mixture by separating the ground from the saline solution. And after evaporation we got water and salt. This might have been your very first evaporation in life. Unless you have never left a kettle boiling when the water evaporated and left the scale on the bottom. Evaporation is suitable if the initial mixture consists of volatile and non-volatile components. But what if the mixture components have very similar boiling points, such as petroleum, and what is volatility? So first things first. Separation of components with similar boiling temperatures can be obtained via simple distillation. This is a process of mixture evaporation and condensing of the resulting vapors. This can be applied for mixtures which components' volatility varies a lot. Simple distillation is normally applied for preliminary high-level separation of liquid mixtures, for example for separating ethanol from a homebrew. Deep separation of liquid mixtures that are soluble in each other can be obtained via fractionation. But before, we first need to dig into volatility. Volatility is a material quality which describes how readily a substance vaporizes. This parameter determines the vapor composition. It will contain more highly volatile or low boiling component compared to the initial mixture. Vice versa, the non-evaporated liquid will contain more low volatile or high boiling component. Fractionation applies this different vapor pressure to each liquid comprising the mixture. The process includes repeated interaction of vapors with reflux, liquid obtained by partial vapors condensing. This process occurs in the fractionating tower. Initial mixture is fed to the feed tray. It is usually liquid, but sometimes it can be vapor or vapor plus liquid. It divides the tower into two sections, the top rectifying section and the bottom exhausting section. The liquid flows from the upper tray to the lower one, and while contacting the ascending non-equilibrium vapor, leaves the low boiling component and takes away the high boiling one. As a result, a product with a low boiling component comes out of the top section, and the vat residue consisting of high boiling component comes out of the bottom. If you want to learn more about the fractionator and other topics of the oil and gas industry in simple terms, like this video and subscribe to the channel. RTSIM – Simulate Environment for Safe Experience.